Pure water and safe food are the foundation of life. We need them to survive. Without clean water, we can get sick. Contaminated food can also make us ill. Protecting our water and food sources is crucial for our health. But our environment faces many threats. Pollutants from factories, farms, and cities can contaminate our water and food. These pollutants can travel long distances, making their way into the air we breathe, the water we drink, and the food we eat. Understanding how these pollutants move is the first step toward protecting ourselves. Scientists use a method called fate and transport modeling to understand how pollutants travel. Think of it like tracking a lost package. Scientists identify where the pollution comes from, the origin. They study how it moves through the environment, the path. They determine where it ends up, the destination. This involves complex calculations and computer simulations. These models consider factors like wind speed, rainfall, soil type, and the chemical properties of the pollutants. By understanding these factors, scientists can predict how pollutants will move and where they will end up. Pollutants can travel through the air, water, or soil. Air currents can carry pollutants far from their source, like smoke from a factory. Rain can wash pollutants from the soil into rivers and lakes. Pollutants can also seep into groundwater, contaminating our drinking water. Some pollutants, like pesticides, can stick to soil particles. When it rains, these particles can be washed into rivers and streams, eventually reaching our drinking water sources. Others, like heavy metals, can accumulate in the sediment at the bottom of lakes and rivers, posing a long-term threat to aquatic life. Pollutants don't always stay the same. They can change their form as they move through the environment. This process, called transformation, can make them even more dangerous. For example, some pesticides can break down into simpler compounds that are more toxic than the original pesticide. These transformed pollutants can have a greater impact on human health and the environment. Understanding these transformations is crucial for assessing the long-term risks of pollution. Section 5. The silent threat. Heavy metals and pesticides in our food and water. Heavy metals like lead and mercury are particularly dangerous pollutants. They can accumulate in the body over time, causing serious health problems. Lead can damage the brain and nervous system, especially in children. Mercury can cause developmental problems and affect the immune system. Pesticides used to protect crops from insects and weeds can also contaminate our food and water. Exposure to pesticides has been linked to various health issues, including cancer, reproductive problems, and birth defects. Section 6. When pollution hits home, real-world examples of contamination. The devastating impacts of pollution are all too real. The Flint Water Crisis and the Aral Sea disaster are stark reminders of what can happen when we ignore the dangers of environmental contamination. These real-world examples demonstrate the interconnectedness of our environment and the far-reaching consequences of pollution. They underscore the urgent need for effective pollution prevention and remediation strategies. Section 7. The Flint Water Crisis, a stark reminder of lead contamination. In 2014, the city of Flint, Michigan, switched its water source to save money. The new water source, the Flint River, was highly corrosive. It caused lead to leach from aging pipes into the city's drinking water. Thousands of residents, including children, were exposed to dangerously high levels of lead. The crisis highlighted the failure to protect public health and the long-lasting consequences of lead exposure, particularly for children's developing brains. Section 8. The Aral Sea disaster, a tragic tale of environmental mismanagement. Once the fourth largest lake in the world, the Aral Sea has shrunk dramatically since the 1960s. This ecological disaster was caused by the diversion of water from the rivers that fed the sea for irrigation projects. As the sea shrank, its salinity increased, killing fish and destroying the fishing industry. The exposed seabed became a source of toxic dust storms, impacting human health and the environment. Section 9. Predicting the path of pollution, how science helps us stay ahead. Fate and transport models are essential tools for protecting public health and the environment. These models help scientists predict how pollutants will move, where they will end up, and how they might change along the way. This information is crucial for identifying potential risks, designing effective monitoring programs, and developing strategies to prevent or mitigate pollution. By understanding how pollutants behave in the environment, we can make informed decisions to protect ourselves and our planet. Section 10. Cleaning up our act. Using models to guide remediation efforts. Fate and transport models are also valuable for cleaning up existing contamination. By understanding how pollutants are moving through the environment, scientists can develop targeted and effective remediation strategies. For example, models can help determine the best locations to install wells to extract contaminated groundwater. They can also help assess the effectiveness of different cleanup methods and track the progress of remediation efforts over time. Section 11. Safeguarding our future. The importance of understanding and preventing pollution. Protecting our water and food from contamination is a shared responsibility. We must reduce pollution at its source, invest in clean technologies, and support policies that promote environmental sustainability. Fate and transport models are essential tools in this effort. By understanding how pollutants travel and transform in the environment, we can make informed decisions to protect our health, preserve our ecosystems, and safeguard our planet for future generations.